Welcome back. In this case, we're going to look at what we do to equations. In the last video, we saw that we simplify expressions. When there's no equal sign, we turn the expression that we're given into something that looks much more beautiful, aka involves less suffering. When we're given a mathematical statement with equal signs, we're going to say we solve equations. When we work with algebraic equations, we solve them. To solve an equation, what does it mean to solve an equation? It means to get the variable in the equation by itself on one side of the equal signs, and then get a number on the other side. So a solution to an equation has this format: variable by itself on one side, an equal sign, and a single number on the other side. Let's see if we can do some work to solve an equation. When working with algebraic equations, we solve. First things first, so let's imagine that we're walking down the streets of Mountain View, and the local Mountain View thugs that have $1 million houses and don't want us walking there, right? They say to us, hey, here's an equation, please solve it. Well, before we trust those people, we notice this is an equation because it has an equal sign. So indeed, they didn't lie to us. When we're working with an equation, we solve it. I'm going to recommend that you do the exact same thing with equations that I suggested for expressions, which is to rewrite the entire equation in your own handwriting. And then what we're going to do is create a chain of equivalent equations. So in the last case, we were looking at equivalent expressions. This thing is an equation. We're going to now simplify the right-hand side of this equation and create an equivalent equation. Well, to simplify this, we're going to use that Lil Wayne property called I'll make it rain. So here we've got something that looks like 6 minus x plus 4 equal 12. We saw in the last video that we can bring this 4 over here and say that this is 6 plus 4 minus x equal 12. We saw that we can combine these two together and say that this is 10 minus x equal 12. And then what we want to do, again, remember that the whole idea here is that we want to get the variable on one side by itself and the value on the other side by itself. Well, this variable has a negative in front of it. We don't want that. We want the variable by itself. So in other words, we want to get like x equal something. I tend to despise negatives. So one thing that I might do is I might actually add the x on the left-hand side. Anything I do to the left-hand side of an equation, I must also do to the right-hand side of an equation. So here we've got negative x plus x is equal to 0. So 10 stays over by itself. Here we've got something like 12 plus x. Well, we're not done yet because the x isn't by itself. We know that to undo addition, we use subtraction. If I subtract on the left-hand side, I must also subtract on the right-hand side. 10 minus 12 is negative 2. 12 minus 12 is 0. And now I have x equal negative 2. In other words, I have the variable by itself, no other things out, is equal to a value. We call this thing a solution because the variable by itself, the value that we're proposing, is over here. We haven't checked our solution, so there's really a little question mark. Is this true? Well, the really, really nice thing about solutions is we can always check. Let's go ahead and check if x equal negative 2 is indeed a solution. And the way that we do that is we take that value, put it back into the original equation, and then see whether or not we have a true statement. So here we go. Everywhere we see an x, we're going to go ahead and write negative 2 inside. And then what we want to know is this thing true? We're not sure whether or not that holds, so there's a kind of a question mark there. Negative 1/2 times negative 2 would be a positive 1. Today is a Monday, in fact, so 3 plus 1 should definitely be 4. And again, we don't know whether or not these things are true before we check it. 2 times 4 is indeed 8. And then we do see that 8 plus 4 is 12. That equation is true. The moment we know that this value of x produces a true statement, yay, true, we say that indeed this is a solution and we've checked it. Whole idea is when we're working with equations, we solve the equation. The solution has the form variable on it by itself on one side, equal sign value. We say that a value of a variable is a solution if, when we put that value back into the original equation, we get a true statement, which is exactly what we had. This is really, really nice because it means every proposed solution that we come up with, we don't need some authority figure to tell us whether or not that is a solution. We can just take that original value that we guessed, put it back into the equation that we started with, check to see, does that value produce a left-hand side that is equal to the right-hand side? If so, we say, yes, it's a solution. If not, we say, nope, not a solution.